Welcome to this video on alpha-beta pruning in artificial intelligence. As we continue to develop smarter and more capable AI systems, techniques like alpha-beta pruning have become essential tools for optimizing performance and efficiency. In this video, we'll explore everything you need to know about alpha-beta pruning, from its basic concepts to its practical applications. So, let's dive in. Before we get started, let's define what alpha-beta pruning is. At its core, alpha-beta pruning is an optimization algorithm used in game theory to reduce the number of nodes in a search tree that need to be evaluated. This can lead to significant improvements in performance and efficiency, especially in complex games with a large number of possible moves. The basic idea behind alpha-beta pruning is to explore only the most promising paths in the search tree, while discarding branches that are unlikely to lead to a solution. This is done by using two key values, alpha and beta, which represent the best possible score for the maximizing player and the minimizing player, respectively. As the search progresses, the alpha and beta values are updated based on the current state of the game, and nodes that fall outside of these bounds can be safely discarded. This allows the algorithm to prune large portions of the search tree, reducing the number of nodes that need to be evaluated and improving the overall performance of the system. So, how is alpha-beta pruning implemented in practice? There are several different ways to approach this problem, but one common technique is to use a recursive algorithm that explores the search tree in a depth-first manner. At each level of the tree, the algorithm checks whether the alpha-beta bounds have been exceeded, and if so, it returns the current value without exploring any further. If the bounds have not been exceeded, the algorithm recursively explores the remaining nodes in the tree, updating the alpha and beta values as it goes. One important thing to note about alpha-beta pruning is that it works best when the most promising nodes are explored first. This means that the order in which nodes are evaluated can have a significant impact on the algorithm's performance. In some cases, it may be necessary to use additional heuristics or evaluation functions to ensure that the most promising moves are explored first. So, what are some practical applications of alpha-beta pruning in AI? One of the most common use cases is in game-playing agents, where alpha-beta pruning can be used to optimize performance and reduce search times. Other applications include optimization problems, constraint satisfaction problems, and even natural language processing. And that's it for this video on alpha-beta pruning in artificial intelligence. We hope you found this introduction to the topic informative and useful. If you have any questions or comments, please feel free to leave them in the section below. And don't forget to subscribe to our channel for more videos on AI and machine learning.